What's up everyone, welcome back, Patrick here, and in this next video what we got to do is we got to take all these expressions here, we have to express them in exponential form and then evaluate them. So notice that all of these here, they are in radical form. And just to do a quick general review, how do we convert radical form to exponential form? Well, if we have, for example, the xth root of a to the y, that's going to equal a to the power of y over x. And actually this, notice how some of these are going to be in this format, where the root number is on the outside, but sometimes it's going to be within the bracket, and then this exponent is going to be on the outside. And actually this format and this format are the exact same thing, right? So for example, this format, notice that this one is in that format, and this one over here, or this one, versus this format here, notice this one is in that format. And both of these formats, they basically equal a to the power of y over x, right? So here it's a to the power y to the power of 1 over x. If we convert this x through to 1 over x, and then when you multiply these two exponents, you end up with that. Or in this bracket, we would convert a to the power 1 over x. The xth root of a is a to the power 1 over x, and that's going to be the power of y, and that's still going to be a to the power of y over x, right? So you're still just multiplying those to get that final format. So knowing that, we have the square root of 4 here. Now, if you remember, if there's just a square root, there's like a 2, an imaginary 2 over there. And then notice the 4 is not to the power of anything, so there's like an imaginary 1 there. So if we follow that, this would end up equaling 4 to the power of 1 over 2. Square root of 4 ends up being 2. It's plus or minus 2, but let's just keep everything positive here. Now here we have the square root of negative 4, and this here is actually undefined, because you can't take an even root of a negative number. If you're dealing with imaginary numbers, which you may or may not in your class, then you could split it up into this, and the square root of negative 1 we know is I, square root of 4 is 2, so this would end up being 2i. But if you're not dealing with imaginary numbers, then this is undefined. You can't take the even root of a negative number. So even if this was like 4 or 6 or 8, 10, any eventh root of a negative number, it's undefined. However, if this was an odd number, like if this was 3, then there would be a value here. You can take an odd root of a negative number. And so over here, we have the third root of negative 8. Well, this negative 8, there's like a power of 1 there. And so following that, this would end up being negative 8 to the power of 1 over 3. And the third root of negative 8 gives us negative 2, like that. And then here, we have 8 to the power of 4. All of that is third rooted. So notice that it's in this format. So converting it there, we would end up with 8 to the power of 4 over 3, like that. And then to evaluate this, what you can do, you could split this up. That's usually what I do, split up the fraction. And then we would end up with the third root of 8 in this bracket, which is 2 to the power of 4. And that gives us 16. You can also split it up like this, but personally, I like to put the fraction inside the bracket, because then you end up getting a lower number here, and then it's easier to take the low number to that higher number to get the final answer, especially if you're not dealing with a calculator. Here, 8 to the power of 4 is going to take some algebra, versus 8 to the power of 1 over 3, we know it's 2. 2 to the power of 4 is 16. And then this over here, would end up being what? Negative 243 to the power of 2 over 5, following that. So this is the exponential form, and then this I would, again, I would take this to the power of 1 over 5, and then this would go to the power of 2, like that. So the fifth root of negative 243 would give us negative 3 to the power of 2. That would give us 9. And then this here, 81 over 16, the fourth root of 81 over 16. So this is like to the power 1. So if we convert this to exponential form, it'll be 81 over 16 to the power of 1 over 4. Right? Following that, in this case, the a value is this whole 81 over 16 expression. And then we have a fraction with an exponent outside of it, so we can take the numerator to that exponent. We could take the denominator to that exponent. The fourth root of 81 gives us 3. The fourth root of 16 gives us 2. So we end up with 3 over 2. And then finally, number 7, following, notice we have another fraction to the power of negative 1 instead of to the power 1. And then we have the sixth root, so following this exact step, we'd have 729 over 64 to the power of negative 1 over 6, like that. And so this, notice that we have a negative exponent, a fraction to a negative exponent means we could flip the fraction. That exponent changes to a positive, and then we could take that exponent and distribute it, quote unquote, to the numerator and the denominator. Sixth root of 64, or 64 to the power 1 over 6, gives us 2. 729 to the power 1 over 6, or the sixth root of 729, gives us 3. So that ends up being the final answer for number 7. Right, so when you run into expressions like this, just remember this overall rule. Remember these two are the same. Express it in exponential form. And then I personally split up the fractions in a way where I end up with the fraction inside the bracket first to get a lower number here in case you're not allowed to use a calculator, and then you could take that lower number to the power of that higher number to get the final answer.